It says, okay, it says, if both parents are heterozygous, so big N, small n, what is the percentage chance that one of the children may inherit the condition? And you don't just want to give the answer. This is very like in maths, right? Even more so than in maths, where sometimes you'll get away with just, oh, I can do that in my head, and I've got the answer straight away and write down the answer, and there's no problem. But a lot of time in maths, and I'm sure your teachers killed telling you this, and it's even more true in crosses. When it says explain how you obtained your answer, it might not always say explain how you obtained your answer, but what they really mean there is show the full cross. Now I'm going to show you how a full cross works, and it must be fully labeled for you to get all the marks. So let me just explain how that's going to work. Okay, read this stuff here, and I'll show you the cross. Let me just bring that over. So hopefully you can still see that. And let's do the cross. So step one, and I'm going to number these, and this is the 8-step method that I was telling you about. It's very important that you kind of follow this like it's your new religion, right? So the first thing you want to write down, stage one is, and you want to write these words, you want to write the parent phenotype. And if you remember, the phenotype is the physical sort of manifestation, what's the physical characteristics of the organism. So in this case, we're looking at two heterozygous individuals. So they are what you call carriers, two carriers, right? And they're carriers because they don't have CF, but they do contain a CF gene, right? So carrier crossed with carrier. Okay, now we know that because they told us they were heterozygous, so we know that they're carriers. But for all intents, they are normal, as in they don't have CF. So we might just put that in. They are normal, as in they appear perfectly normal. You wouldn't know by looking at them that they are carrying this one copy of the CF gene, cystic fibrosis gene. But because they've given us the info, we can write down what the genotype of these two things is, these two people, right? So these two parents, one of them is heterozygous, and so is the other one. So they look like this. They're both heterozygous. They contain a normal version, and they contain a CF gene. Stage 3. Stage 3 is meiosis, and we put this in, and we represent it by just arrows, okay? And in both cases, and you've seen this, but we just haven't done the full 8-step labeled kind of thing yet. But the arrows indicate meiosis, right? That it's the process by which gametes are made. So stage 4, or label number 4, is you list the gametes. In this case, there's going to be 2 from each parent, and you put the gametes in circles. For some reason, they're kind of into that. The examiners want to see the gametes in circles. Well, we'll give them what they want. So, and it's the same for each of the parents, right? They both produce gametes. And remember, each gamete receives only one of a pair of factors. That's Mendel's first law, right? This is so Mendel's first law applies to monohybrid crosses as well as dihybrid crosses. Mendel's second law, the independent assortment, only applies to dihybrid crosses. This is a monohybrid cross. We're looking at just one allele pair, one gene, a cystic fibrosis gene. Okay, so what are we going to do with those gametes? Well, we're going to fertilize them. And in our crosses, fertilization is represented by a Punnett square. So stage 5 looks like this. You have a cross where you take one parent on the top of your Punnett square, and you put the gametes of the other parent on the other side of the Punnett square, and you combine them, you fuse them, the gametes come together to form these possible zygotes, right? So I hope you're writing along with me here. So now you've got the 4 different possible genotypes for the 4, or the different possible combinations that could give you the offspring of these 2 parents, the children, of these two parents, right? So the children, then you list. So stage 6. Stage 6 is you put the offspring or the progeny. Either word is okay. You do the genotypes of them, and you're thinking, well, they're right there. Just they're in the Punnett square. Yeah, but you want to list them out, right? Trust me on this. So you've got the 4 different genotypes. Underneath that, you put in the phenotypes of the offspring. The phenotypes. So what's this big N, big N? That's normal. Big N, small n, also normal, but a carrier. We might as well put that in there. There's another normal carrier there. And then this last person, I'm going to have to just scooch over here a little bit. This last person is cystic fibrosis. So yeah, so this person has cystic fibrosis, and you can see what the question was looking for, what the ultimate answer we have here now, because stage 8 will write down the answer. It asks if you, what is the percentage chance that one of their children might inherit the condition? And percentage chance is a key phrase here. Stage 8, I said it was the 8-step method. Stage 8 says you write down the ratio. And the ratio in this case is 3:1, normal, carrier or otherwise, to CF, sufferer. Okay. So when you're looking at the ratio, tells you then the answer is there's a 25% chance that one of their children will have CF.